So here I'm going to just run through a few of the figures from a couple of reports, one from TERI, the Energy Research Institute of India, and Shell India that just came out, and one from IRENA, the International Renewable Energy Agency, which put out a report a couple of years ago, just to get an indication of how people think about the future energy scenarios for India and where India stands in terms of where it needs to be with respect to its own nationally determined contributions that were submitted to the Paris Agreement. And this is even before it's going to update its commitments to meet the temperature targets. As we saw in the first podcast, none of the countries are on track to none of the commitments are on track to meet any of the temperature targets, 2 degree or 1.5 degree centigrade, with 66% probability by 2100. India, in terms of its NDC performance, is got kudos for doing well, but here we are anyways. So India is delivering on its first Paris Agreement NDC, reduce carbon emissions intensity of GDP by 33 to 35% by 2030 from the 2005 level. So it's not the absolute reduction, but it's the carbon emission intensity of the GDP with respect to 2005 level. So here is fuel combustion CO2 per GDP, grams of CO2 per dollar constant US 2010 base, and you can see here this is the goal trajectory, and here is where India has been in by 2019 or so, and you can see that the goal is over here by 2030. That's the commitment, seems to be on track. So although the nationally determined contribution goal covers all emissions, here we present the progress for energy system, the major component of the total. Okay, so obviously it has to go there and then also accelerate to meet updating its commitments or updating its NDCs. 40% cumulative electric power installed capacity from non-fossil fuel based energy resources by 2020. So that's the trajectory it needs to be for its Paris Agreement commitment, and this is the trajectory it's on from 2010 to the end of 2019, I think. And you can see that it's on a much faster track. So again, impressive. But what we looked at before was the number of clean air days, and we haven't even looked at water pollution. So there is still those issues, and there is the energy poverty issue, energy security issues, which have to also be considered as co-benefits of the commitments to Paris Agreement and the action on that. To create an additional carbon sink of 2.5 to 3 billion tons of CO2 through forest and tree cover by 2030. So this is forest sequestration of gigaton of CO2 per year. So this is the trajectory it's been on. The current projection is over here. So you can see that it's expected to meet its commitment, and the details are somewhat more complicated than that. There are issues of conflicts with people who depend on forests for their livelihood, like the tribes that live in and around forests. There are conflicts between like tigers and humans. There is land being acquired for planting trees and afforestation and so on, but nonetheless there it is on a good trajectory as well. Opportunities to electrify exist in every sector. So this is just looking at electricity share of final energy consumption, including off-grid power supply by solar and wind and other. and you can see here going from 2000 on to 2030 and beyond. Looking at transport, so obviously rapid rise in hydrogen in transport would reduce the electricity market share, so that's the low carbon fuel. Lots of issues in terms of scalable production, transportation, recharge stations, etc. Industry, not as fast, so it needs to step up, I suppose, but the share of final energy consumption is about less than 30%. Agriculture is up here. Obviously could use electrification, and there is a conflict in terms of food, water, energy nexus. One has to watch out for this because often electrification of agriculture comes with groundwater mining with pumps for irrigation, so one has to watch out what electrification actually means in that context. These are the commercial applications. Residential expected to continue to increase, reaching 100% of its energy consumption from electricity, hopefully including lots of solar and wind. So this is not saying which energy, but it's just the share of final energy consumption and how much of it is electricity. Hydrogen plays a key role in decarbonizing industry and transportation sectors. So going into the future, this is the trajectory. Natural gas as final energy is projected to decrease. Remember, once we go beyond 2020 or so, these are all projections. Various assumptions go into it about how the system will be renovated, how many renewable energy sources and capacities will come in, how the economy will grow, what population growth will be like, etc., etc. Nonetheless, you can see hydrogen industry and hydrogen transport will be needed to play a greater role in decarbonizing the industry and transportation sectors. Power generation grows, dominated by wind and solar. So the past from 2000 to 2020 or so has seen, of course, an increase in solar and wind, but coal shows a great increase out to almost 2025 or so, and then ramps down slowly and will be projected to be eliminated by 2045 or definitely by 2050. If air quality is a concern, then obviously this could be accelerated as wind and energy may grow faster than projected here. So there is solar and there is wind, which dominate the power generation in terawatt hours by per year by 2050, which is a good news, of course, and still has to be monitored for its impact on global targets and what India's role will be in global climate actions. Bioenergy is transformed, primarily fueling transport and industry by mid-century. So biomass as final energy in million tons of oil equivalent per year includes biodiesel in agriculture, liquid biofuels in transport, biocompressed natural gas in transport, biogas, biomass for industrial use, light commercial, and traditional biomass in homes. So this is the bad news right now. Significant amount of traditional biomass is still used in home and is not going to be phased out very quickly. So this has all kinds of issues. But biodiesel and biofuels also have to be watched out for, because competition with food grains, food availability, food prices for the poor, and so on also have to be managed. So these are projections which don't necessarily always worry about those kinds of details, but they are just considered as ways to reduce emissions. So carbon intensity of energy production is what is the main concern over there. Technology and nature are required to remove remaining emissions. Obviously, that's the baseline, almost business as usual going off in terms of greenhouse gas emissions, CO2 equivalent, so gigatons of CO2 equivalent per year. Net zero emission scenarios. Net zero scenario with reforestation brings us further down compared to the baseline, and net zero emission scenarios with reforestation and carbon capture and sequestration would add more. But these again assume certain things. For example, scalable carbon capture and sequestration. Where will it be developed? Will it be made available to countries like India? Will India develop it indigenously? Will it be scalable? Where will it be stored? And so on. So all those issues have to be addressed. Deep electrification of the economy, predominantly from renewables. Molecules are still required. Basically, talks about hydrogen and so on, which are low carbon fuels. So that's what is meant by there. So this is the final energy demand in million tons of oil equivalent per year. So going into the future, the projections say what natural gas and hydrogen will do. This is the electrification potential that has to be accomplished in terms of electric vehicles, for example, which may be easy for the two or three wheel vehicles which dominate right now, and the cars that are coming online. Of course, there is a question of the infrastructure for recharging, etc. Plus how to transform the other transportation vehicles like trucks and so on to electric vehicles. That's the bigger question as well. Oil products have to be phased out. Coal still remains here in terms of the energy mix of energy demand, which is not good. Bioenergy and electricity, which includes solar and other molecules, as is referred to here. This is a broad concept of transforming to a net zero emissions energy system. I don't know if I'll go through it, but you can look at the transportations sectors, energy use, so transport, agriculture, industry, commercial, and residential. And then there are time horizons, and there is emissions of CO2 equivalent which have to ramp down. And this is the final energy use by 2050 in terms of transport, agriculture, industry, commercial, and so on, with nature-based projects like maybe recovering mangroves, recovering salt marshes, wetlands, etc., and CO2 capture and sequestration. Coal use in heavy industry continues beyond 2050 here, so obviously these have to be managed. But you can see everything is in here in terms of industry, transportation, hydrogen trucks, biofuel demand, wind power, coal for use in power generation ends here. So carbon capture and sequestration can make some of these more friendly in terms of emissions if they can be captured at source and reused or sequestered and so on. But lots of details in the assumptions made and so on. And from the IRENA report, International Renewable Energy Agency report, growth in key economic and energy indicators for India going from 2014 to 2030. So different time horizons are used. I would consider 2030 as a more immediate horizon because lots of targets have to be hit by 2030, even though 2050 is not that far away in terms of infrastructure needed for large energy projects, especially especially hydro and nuclear, if they are going to grow as well. So here is the expected growth in terms of percentages. Population is expected to grow up to about 20%, but this could change depending on how quickly women get educated and population goes down. Total energy consumption is expected to grow about 80% in this period. Total primary energy supply, so direct fuel and other sources. Power capacity expected to increase by 140%. GDP per capita expected to increase over 160%. This is great news, of course, for a country like India. It's the main goal of economic growth and the ambitions around it. This is also good, corresponding to the increase in GDP per capita. But again, keeping in mind that we want to go to net zero, then all these options have to be kept in mind when power capacity is grown. Not only for meeting Paris goals, but also for improving its own air quality. Even if you increase per capita GDP and air quality keeps degrading, for example, then there are losses in terms of labor, hours, productivity, plus of course health costs are going to go up tremendously, especially for the children and the old. Of course, appliance ownership is also part of the news. You can see air conditioning shoots pretty high if the warming continues as projected. So by 2040, that's going to be a unit for household of almost 2. So with the GDP increase comes this air conditioning demand. Televisions and luxury goods like refrigerators shouldn't be luxury, but as we saw in rural areas, there are very few refrigerators, but with economic development and per capita GDP growth, it is going to become part of the family life. Personal computers, washing machines, dishwashers and dryers. So these are things that add where efficiencies can matter, but how they are run can also matter as well, where the electricity will come from. Passenger car sales by scenario. So this is from the IRENA. I think this is from the International Energy Agency, which looks at the stated energy policy scenario, India Vision something, and sustainable development scenario. So this is basically how recovery will happen beyond 2020 after COVID and so on. So basically talking about hybrid vehicles, electric vehicles, and CNG vehicles and so on in different scenarios. Okay. This is the change in fuel. I don't know why the IEA symbol got cut out of all of them. Just be sure that this is from the International Energy Agency report, and I'm directly taking them from there. Change in fuel supply and installed electric capacity by scenario again, 2019 to 2040. So this is slightly different than the Terry Shell report, but again, essentially talks about reducing traditional biomass and increasing solar and wind, obviously needed to meet not only NDC goals but to remain low on emissions and air quality. Changes in coal and solar capacity and share of power generation in India in the stated energy policy scenario from 2000 to 2040. So change in installed capacity going from 2010-15, what has happened already. Solar increasing, coal decreasing, but coal has to go away, and then solar has to increase tremendously in terms of gigawatts of installed capacity. Share of power generation, coal has to drop off very quickly down to less than 25%, and solar has to pick up the slack. And of course there are wind and other like hydro, there are small hydro, there are possibly nuclear and geothermal, etc. Okay, there are many maps which show the potential for various energies like wind, solar, geothermal over India. In terms of being a player at global scale, India, if it has a large share of global renewable portfolio, so you can see what's expected in 2030 from the IRENA report from 2017. Sorry about that. I flipped out of the display mode going back. So even rich countries like US only have 15% expected, Canada only 2%, European Union as a whole 14%. This is important because even though all these countries are very climate friendly, progressive, very keen on commitments to Paris Agreement and so on, their portfolio of renewable energies is not that large. So if India comes in at 9%, China is very ambitious going up to 20%, and India obviously can be in a strong position for its own energy security and reducing energy poverty, but also a strong player at the negotiating table for itself, saying it's playing its role in reducing emissions and increasing renewable energy contributions to its GDP growth and reducing its carbon intensity of GDP growth and so on, right? So it's critical for India to have its own co-benefits internally, but also have an eye on its role in the global action on climate as it goes into the future. So that's just a very brief run through. This is a very vast topic obviously, and I'm just giving you a very brief glimpse, but I hope it's useful before we get into the solutions. I will start with the book Drawdown and then move to other books. Okay.